Hey everybody, this is Larry. This week on with Q4 of the weekly contest 259, longest subsequence repeated K times. So this one was a very hard problem. It took me a long time. It took me about half an hour. And a lot of that time was just sitting around doing nothing, to be frank. I wanted to, this is a hard problem, so don't feel that bad about it. Okay, so a couple of things. Hit the like button, hit the subscribe button, join me on Discord. You can join the K times if you like. There are a lot of good contest people there recently. So Leetcode contest. So yeah. Anyway, for this one, I took a long time, but there are a couple of observations that I needed to make. First of all, the first one that I did make is K. This K times 8 thing, right? What does that mean? K times 8 means that the length of the longest subsequence can be at most 8. You can kind of, the way that I visualized it, and you can see me doing this during the video next when I solve the live during the virtual contest, is that, for example, when K is equal to 2, N is equal to 16, so that means that the longest way this is going to be doing is just by 8. So 8 is always going to be the longest subsequence. You will never need to check more than that. Yeah. Now for K is equal to 3, N is equal to 24. You can kind of see that more a little bit. I know that this is maybe a little bit silly, but that's how I did it to see it. The other thing that I noticed earlier on is that given the longest subsequence, for example, let's just take this one, right? And given that K is equal to 3, for example, it doesn't really matter. And you know that the best answer is B, 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 B. What does this mean for us? This means that this is a terrible way to explain, but maybe it'll be fine. Yeah, this is kind of a terrible thing. But, okay, they don't give us a good, I don't have a great example. But the idea is that, okay, this is a good answer. And what does that mean, right? I mean, obviously, this is the best answer even, not just a good answer. But that means that BBB is also a possible answer. I mean, it's not the actual answer, but it is a valid answer, right? It's a, let's just say valid subsequence. It's just not the longest, right? And so is BB and B. So that's the first thing I noticed is that because of this case, you can build this backwards. So I thought about doing breadth first search and was about to YOLO on this actually. I don't know what, so I spent like maybe 20, 25 minutes, I don't know, you have to look at the tape. I spent a long time just trying to figure out how to analyze this complexity. And I didn't do a good job, to be frank, so I don't know if I'm gonna analyze the complexity here. But yeah, knowing this, I thought I could do a breadth first search backwards, right? Meaning that I can start with, let's just try A, let's try B, and then if A is good, then you try AA, AB, and then you try BA, BB. I don't know if AA is good, AA may be good. If it's good, then you try AAB and so forth, right? But of course, if AB seems like it should be good, but yeah. Actually try AA first. And AA is no good, so you remove it, but that means that you don't get it next, right? Very general breadth first search things, to be frank. But yeah, so that's the idea that I started implementing, and you can see this in the video. Then one thing I noticed, which doesn't show up here as much, but let's say you as I was coding this breadth first search, I thought about one thing that I noticed that I'm going to just shrug. But let's say you try, in a brute force kind of way. We said before you tried A, you tried AA, AB, blah, blah, blah. But then, in actuality, you also probably have to try AZ and so forth, right? Or even just before that. But this is just a better visualization. I think this is actually true one step before. But what does it mean for AZ, right? If AZ is not a subsequence, a good subsequence or whatever, a valid subsequence. So it turns out, So it turns out that if you think about how these subsequences work, and I had a breakthrough when I was coding this, is that it means that A star Z is not a valid subsequence, right? What does that mean? That means that that means that there's a star, meaning it could fill anything. That means A star C is not a valid sequence. Like, so this is not a good sequence. 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 So forth, right? It means all these things. And I don't know that I have a good visualization about it, but you can think about it through where, okay, if AC is no good, adding a new character is not going to be good. So that's the second thing that I noticed, even though maybe it's related to this prefix thing a little bit, the same idea, but now extended this way. So then now, noticing this, we're able to then, it's just to keep track for an optimization to be like, okay, if Z is no good on this prefix, then we just keep track of all the possible ones, right? So here I keep track maybe AA, no Z, or maybe even no Y, no Z, whatever, ... right? And so forth. So now what that means is that instead of a possible brute force where, okay, we have 8 characters, but it'll be 26 to the 8, every time we eliminate something, that there's no longer a true case. There's probably a better way to do this tighter bound, but I'm struggling to find that right now. But I think, because I think you can actually do some pigeonhole math on the fact that, the biggest number is going to be so then that means, so this is the biggest n. So because this is the biggest n, the possible n, because this is the biggest n, you can do some math around how many possible valid subsequence to check. I don't really have one for you to right now. I'm in Spain, so I'm on vacation mode. But that's these are the ideas that I had during the contest to these are the ideas that I had during the contest to kind of think about that. I think this should be fast enough. Anyway, so that's basically my implementation. And of course, each check is O of n because you just have to go for the array ones or the string ones, right? So I just think that there's not that many valid subsequence because it is bound by. So in the worst case, I think this should be n squared, but I don't know that you can construct an n squared case. Maybe it's k squared actually, but I don't know. Anyway, I'm talking about a lot of stuff I don't know. Maybe that'll be homework for you to play about the complexity. But I did, this. I have this check function. This is O of n. This is basic O of n stuff. Like, you just go with array, you count, and then subsequence math. So so I hope you get that part. So let's put the Q down here so it's a little bit easier to read. But basically here I use a bit mask, which I'm not going to go over in this video, but basically it just contains 26 binary bits for me to do a Boolean lookup on, and one for each character of the alphabet. You start with an empty string because that's how you do it. This is standard breadth first search stuff. The current is equal to possible. I keep saying breadth first search, but maybe it shouldn't be called breadth first search. But these are just the possible characters to check. And then this one is just standard, checking for the best, right? Which is the scenario they tell you. You have to either get the longer one or the lexicographically larger one. Otherwise, you do this thing, right? So if the character is possible, then we do a check on it, right? And this check is what we said before. So this is O of n. If this is good, then we put the character into the next queue. The reason why we don't add it straight to the queue is because of this thing, right? We want to check Z. If AZ is no good, that means that for AA, even if AA is good, we don't add a Z later on, right? So for that reason, I grouped everything to the same, and then I calculate the possibilities together. So yeah, so if it is good, we add this to the possible queue list for the next queue, and otherwise we update possible. We flip it off. Again, I'm not going to go over the bit mask on how this works, but basically we switch from a possible of 1 to 0 to make it not possible to use that character X in the future. And then now, after we do it for all 26, we then, or 26 characters, we add it back. Now this possible is actually the, we moved every not possible characters, and then we add, this is just a string concatenation and add it to the next queue. So yeah, that's all I have for this one. The complexity, like I said, I don't really know. Let me, yeah, but that's all I have. Let's see how fast this runs. I usually don't care about how fast it runs, but for this one, I actually, because of the complexity, I don't know the complexity and stuff like that. Yeah, I would like to see how fast that goes. Okay, whoops. 36% submission. Okay, let's see. So it actually went pretty quickly, so I'm happy about that. Let me also just take a look at this discussion while I'm here. But 2 to the 8, huh? Maybe there's a better way to do it, but let's see. Yeah, okay. Now try doesn't make sense. The number of routed sequences is what? I don't know. I don't know if this is true, but maybe that's right. Yeah, maybe that's right. I don't know. I don't know. I mean, that is the number of possible subsequences of length 8, but that doesn't seem like it takes account different possible characters. But yeah, I don't know. Maybe I'm just wrong on this one. But yeah, anyway, that's all I have. I hope this explanation of this thing makes sense. I'll see you soon, and watch me solve it live next. Okay, there we go. Misread the problem. Okay, longest subsequence repeated k times. Usually I do a refresh to see number of total people accepted, but of course this is a virtual contest, so you can't really see that. So I'm just going to do a virtual thing here. Congrats to the people who already finished. Wow, they took about, even say K took about 10 minutes on the number 1, so that means I have some time to catch up. Q3 really, I mean, I just misread it, so it is what it is. Okay, so you give me a string S of length N and indicate longest subsequence repeated K times in string S. Okay. I know what a subsequence is. Okay. If sequence something. Okay, so let is okay. K is 2000 and N is 1600. Okay. What does this 8 mean? Does 8 mean anything? Let's think about this. I don't know, like 10 minutes. Wow, I don't know. I don't know what I could do in 10 minutes, but there's more than twice. Empty string is returned. That's pretty impressive. I don't even have any inkling, but it took them 15 years. They probably don't have any inkling either, but this means that it's probably going to take me a while. Okay. Mm, well, I'm thinking right now of something like a breadth first search because I don't know if that's quite the way to do it, but because if, mm, because every every prefix of this is a subsequence that is repeated k times, right? So that leads itself to be a breadth first search even, but that may be too slow. Plus B, you go through K, so you start with, so with a long enough thing, you start 26 times through the loop, and then yeah, it gets pretty expensive. I don't even know. I don't think that's feasible for six. Oh yeah, no. K is 2,000, so N is 16,000. That gets expensive very quickly. Hmm. So you have to do something maybe slightly smaller, but that's an idea that we can think about it. Uh, so how do we get you when BPA is 3? They repeat it 4 times. So, yeah, and of course you. Hmm. Hmm. Think about it backwards. Well, I'm trying to think about it backwards. Does anything in this, can we impose anything on it? Hmm. Well, I don't know. Huh. How much time do I actually have? Anyway, I have another hour, so it should be okay. Hmm. My virtual rank is not very good because this is like the problem. Should have been faster. Anyway. Hmm. Good thing I didn't wake up for this one, but hmm. What are these subsequences? because the subsequence is probably not a try or anything like that. Only idea I still have is just to buffer search, but it still feels very expensive. Maybe? But 16,000 characters is a lot of characters to to go, because it's just easy to go. Or it's just easier time limit exceeded, right? Because if nothing else, you just have thousands of them and then you go for the entire list. That would be a mess. Oh wait, 8, 8, 8, 8. What does this 8 mean? That means that... Oh wait, 8 means... What does that mean in English? That means that, okay, so let's say K is 5, right? And N is equal to 40. Okay, what does that mean? What does that mean? What does that mean? Let's see. That means that the longest length is of length 8. So the longest possible... Is that right? Let's say this is 2. This is 16. Okay. So the longest possible length would be of length 8. So, okay, let's think about that. I mean, 26 to the 8 is still going to be too slow, but that narrows... That narrows it a little bit. Okay. Yeah, okay. So that means that the longest string is going to be of length 8. Okay, now can we do buffer search? I think one answer can even put that 2 answers. You are much smarter than me. Much. Okay. That means the answer is going to be at most 8. That still isn't good enough for me to figure out the answer there. I don't know. I don't think. But that's still too many characters. For lowercase to be subsequency. I have to make one more observation. Like, you can't just brute force, and I think that's exactly what I'm doing. That's 26 today. That's pretty long. Okay. That's 16,000 characters. You're going to do 100 operations, that's only 1 million. So that's expensive pretty quick. Okay. So what can we do to take advantage of the fact that the longest thing is going to be 8? Something more brute forcey, maybe. Is there any grouping type things that I can think about? Like, well, if the 2,000, okay, let's think about this. Composition of the input. Like, What I'm thinking now is whether it has to be forced in the first like eighth or something like that, but I don't think so. But let's just say k is equal to 1 and is equal to 8. What does that mean? Right? That means that, well, here in this case, the answer doesn't have to be in the first quadrant or first whatever. What 16, right? Now in this case, you could just have this, and the answer will have to be in the last half. So I don't know that has to be in any particular portion. And for example, we have 3 and 24. So yeah, so in this case, your answer is still going to be H. So there's no easy way to kind of just narrow it to any section. And any kind of check on whether a sequence is there will take too long. Okay, what does the 8 get us? What does the 8 get us in brute force? There's no way to divide and conquer anything. That's why I'm trying to think and visualize this a little bit. Okay. What's 2 to the 8 anyway? In case we need to do something like that. 256 times 16,000 would be good enough if we could only use whatever, but that's not the case. In chunks of 8, it's distributed across 8. Okay. This is a different answer, I guess. What is the okay? I don't know that helps so much. I am stumped. I have no idea. If it was binary, this would be easier, but trying to figure out how to exploit the 8 port. Can we break it into 8 chunks? In this case, does that do anything? I mean, it's very coincidental for this one, but for something like this one, it doesn't mean anything because the answer could be 8 now. So the 8 chunks don't really do anything. Yeah. A lot more people got it. Wow. Well, 24. So this is a hard one for sure. Maybe I will just ask for myself too much. What is the worst case that is possible? Like, dot. There's a case here too. So n has to be equal to 16. So I guess that's maybe it. Yeah, I'm gonna try to put for my first search because I have no idea, and we'll see if we could get a case to get it. But yeah, yeah, okay. Okay, and then now this part is always a little bit awkward, but let's see. Okay. That's not quite right, I think. Because that doesn't go through the entire alphabet now. It's weird. I just copy and paste this, but what is this? Yeah, why does this not go to 26? Like, this is what happens when you copy code. People do weird things. Let's see if we could eliminate something. If AZ is... I see. There's one more observation, which is that it's not just a prefix. Every subsequence of this has to be good as well. So that means that if AZ, for example, is not a possible answer, then A star Z is not a possible answer. Okay. How can I write this in a good way? Okay. I think that's the big one. That I think now I have an idea to kind of do what I'm doing now, but better. Let's do this, but okay. Yeah, okay. And then now let's see. x is in range 26 if x to possible. If this is possible, then we is this just then we take the character so so this is the next string. Let me print that out real quick because I am really bad today. Okay, pending for some reason, that should be really quick. Okay, maybe. Okay, Current is empty, but then where's the A? That's why I'm looking up and down. Okay. Oh, this is just me being dumb. This is 1, 2, 2. Okay. I've made that mistake a couple of times recently. It's really bad. Okay. Is this an activity? Let me check. I don't know why I added a B. That's pretty bad. But okay, just checking that there's no empty string. Okay. Okay, so then now we do check. If we check this and it is good, then we next Q is equal to, let's just do this. Then next dot append X is a possible case. Let's go NQ for next Q. Otherwise, this is not possible anymore. So possible, we shift it by 1 to that. And then at the very end, now we put everything in the next queue into the queue, but with this new possibility of, because basically we eliminated these possibilities. So yeah. I hope this is true. I actually don't know if this is true, to be honest. But yeah, for item in queue, Q dot append. Let's see what we're appending. Current plus item, and then possible. Okay. And then I would implement the check. Let's just say that in T for string. That doesn't really make sense, but okay. Yeah, okay. For X is in range. Okay. How is 0? Pointer is equal to 0 as well. For X and S, if X is equal to T of pointer, pointer increment. If P is the length of T, let's call it M for length of T. P is equal to M, P is equal to 0, with 1, return count is greater than K. Okay. Okay, let's just print out all the currents and then we'll see if this works. Oops, what did I click on? I guess that question mark probably. One time error, that's not good. You can only concatenate. Oh, X is a whatever, so I meant this to be ordinance of I need to fix that. And this is slow, so I need to fix that, but we'll do some of the math. Okay, so we have the right answers for all of these, but is it going to be fast enough? That is the real question. Yeah. And we should... if length of current is greater than length of best, and best is equal to current, else if length of current is equal to best, then best is current is greater than best, and current is equal to best. Oops, the other way around. I'm just going to YOLO submit, to be honest. There is a couple of things I could have done. Let's see. What is order means of A? I think this is a little bit, this adds up a little bit because we might do it a lot of times. 97, okay. So let's just change that. But that's a very minor optimization. But I am definitely worried about running time. So let's give it a submit. I don't know. If I time limit, I time limit. But I think, well, I think a time limit I'm okay with. Wrong answer is the one that I think that would be maybe interesting. Of course, what's more would be more interesting is if this works or this got submitted. Did this get submitted? No submission. Right? Let's refresh. I don't know what happened there, but okay, this seems okay. So let's give it a submit. Yes. Okay. Wow, this is a hard problem, but I'm happy that I got it. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this problem and explanation. Yeah, stay good, stay healthy, to good mental health. I'll see you in the next problem. Bye-bye.